Welcome back, learners. So as we have discussed the design of biaxial loaded column in the previous video, so today let us develop the Excel sheet for the design of the biaxial loaded column. But before I start the Excel sheet, I would like to make you very clear that whatever the Excel sheet that we are going to follow, it is completely as per the theoretical concept. So as I have informed in the previous lecture itself, that if you are following this procedure in the practical approach, it is very difficult because you have to do n number of iterations. So therefore, in the next lecture, I will be explaining the developing the Excel sheet for the biaxial loaded column, which we can adopt practically in order to do the design of columns, right? So therefore, let us give the heading like this, okay, that is biaxial loaded column design. Okay, yes, so this is the heading that we can give. Okay, yes. Now in this, the first and the foremost input that you are supposed to give here is the grade of concrete. Okay, I can give the naming like this. So the first one, okay, I can give like this. So grade of concrete. Okay, the grade of concrete. So the grade of concrete, usually it will be represented in the form of FCK. I can write FCK. Okay, and usually the grade of concrete, let us take now as 25. Okay, so let us take that as 25. Okay, yes, so that is the first step. So that is grade of concrete. The second step is after the grade of concrete. So the next you required is grade of steel. Okay, so the grade of, instead of saying steel, I can give rebar. Okay, I'm going to represent it as Fy, and that let us give it as 415. Okay, 415 Newton per mm square. That is nothing but your grade of rebar. So next you have is, the next you are going to have is the shorter dimension of the column, or you can say I can give the column dimension in one direction, that is much more better. Okay, so column dimension in one direction. Okay, so let us give that the value as, let us give that as B, and let me give that value in mm as 400. Okay, then the fourth one, I can write column dimension in one direction, I can write in another direction. Okay, in other direction, let us give that as capital D, and let us give that value as 500 mm. Okay, yes. So the next that you are going to consider here is, so none other than the axial load on the column. Okay, so that is nothing but the fifth one, axial load on the column. So let us give that as PU. Let us give that as PU. So for the sake of example, let us take it as 1600 kilonewton. Okay, if you want, I will just insert. So this will be Newton per mm square. So this will also be Newton per mm square. This will be mm kilonewton. Okay, yes. Now as I already explained in the previous lecture, that here without considering the percentage of steel, okay, without considering the percentage of steel, so we cannot able to solve this problem. That's why I told you that it is an iteration process. So let us assume the percentage of steel. Okay, let us assume the percentage of steel, or the P by FCK value, I can say the P by FCK value, let us assume it as 1. Okay, I can write percentage of steel considered. So let us give that as P. Okay, so that will be, let it be in the percentage. Okay, so that let us consider it as 1%. Okay, then next you have so the next will be P divided by FCK. Okay, so P divided by FCK value. Okay, P by FCK value. So I'm going to have P by FCK value, so no unit for this. Okay, yes, so no unit, right? So then I can assume P by FCK as, now it is 1 by 25, right? So I can make this as, so 1 by FCK, which you are going to get 0.04. So now once I got that, so let us take the larger dimension. Okay, let us take the larger dimension of the column, that is d dash by d, right? So therefore I'll go to the 8th step here. So let us find out, so I have to write effective cover to the column. Effective cover to the column. So that is nothing but your d dash. Okay, so that will be in mm. I'm going to give effective cover to the column as 50. Okay, so therefore I'm going to find out now d dash by capital D value, d dash by capital D. Okay, so this will be d dash by capital D. So no unit for this, so I can find out it as this divided by capital D, so which will be 0.1. Okay, so which will be 0.1. Now after that you find out the value of Pu by FCK BD. Okay, so you find out Pu by FCK BD value. Okay, so that is the 10th step. I can write here. Okay, so this is the 10th step. It is Pu by FCK into B into D. Okay, that is Pu by FCK B into D. So this value I am supposed to find out. So same here. Okay, so no unit. I am supposed to find out Pu by FCK BD. What is the value of Pu I have? The value of Pu is 1600 into 1000. Okay, divided by, what is FCK? This one. What is B? This one. What is D? this one, right? So that is PU by FCK BD, which you are going to get 0.32. Now for the corresponding chart, that means considering the column as a rectangular column and providing the reinforcement on all the four sides, and D dash by D value as 0.1 and Fe415 as grade of steel. So go to the corresponding chart. According to this, if you go to chart 44, okay, if you go to the chart 44, so there from PU by FCK BD value, that is 0.32, and to the corresponding D dash corresponding P by FCK as 0.04. If you go to chart 44, I can say, okay, I can go to chart 44. Yes, so this is chart 44. Okay, so the corresponding 0.32 value, okay, that is 0.32, and corresponding 0.04, that is here. So I can get the value of mu by FCK BD, mu by FCK BD as 0.08, that is here 0.08, 0.09, 0.1. So mu by FCK BD is 0.08. Okay, so 0.08. So therefore I can write, so 11th step, it is mu by FCK B, mu by FCK BD square. Okay, so that value you are going to get, so mu by FCK BD square. Okay, so that mu by FCK BD you are going to get as 0.08. Where you are going to get? You are going to get from the chart. You can write here from the chart. So once you get mu by FCK BD, then you calculate mu x1 value, right? So how you get this mu x1 value? It is mu x1, right? Yes, this is mu x1. So what will be the corresponding unit? The corresponding unit will be in kilonewton meter. Okay, so how you get this mu x1? It is none other than this value, that is 0.08 into FCK is 25 into B is 400 into D 2 times 500 into 500. So that divided by this value will give you mu x1 in kilonewton meter, that is 200 kilonewton meter. So once this is done, okay, that is with respect to D dash by D value. So you can insert one here so that no doubts will come. Okay, yes. Then next I can go here, I can go to 13th step and I can find out D dash by B value. Okay, D dash by B value. Okay, so this is D dash by D. Now I will go to D dash by B. Okay, yes, I am going to find D dash by B. No value for this, so that will be, what is the value of D dash? This divided by B value 400. That will give you 0.125. Okay, so 0.125. So therefore I can go to the actual chart of 0.15 because 0.125 will not be available. You can go to the higher chart, that is 0.15. Okay, 0.15. So that is D dash by D value. So again I can write this step, that is nothing but your P by FCK BD value. Okay, that is P by FCK BD square, FCK BD, that is into 1000, this into B into D. okay, that is 0.32. okay, so that is your P by FCK value will be 0.32. okay, so P by FCK will be, sorry, that is the PU by FCK will be 0.32. Now go to the corresponding chart of 0.15 with the rectangular column with reinforcement on 4 sides and Fe 4 on 5, and you can get the value Mu by FCK BD. okay, you can get the value Mu by FCK BD from the chart. okay, so Mu by FCK BD from the chart you are going to get, okay, and that Mu by FCK BD value will be 0.078 that you are getting from the corresponding chart. okay, so once you get this, so next step is, now instead of taking Mu x1 you are supposed to take Mu y1. okay, so that will be Mu y1, okay, which will be in kilonewton meter only, right? So now therefore how much you are going to get Mu y1? It will be this into FCK into B into this into FCK into, FCK into 2 times 400 into D. okay, so that is 156. so that is corresponding Mu y1 value. So once you got Mu x1 and Mu y1, as per the previous lecture, that is the steps that you are supposed to follow, we have to find out the value of PUZ, right? So the next step is, I can give one value, I can give one space here, then I can write the 7th step as calculation of PUZ. okay, calculation of PUZ, right? Yes, okay. Now we have to go to the chart 63 now. okay, so as per the theoretical procedure of the design of column, go to 63 now. So when I go to chart 63, you can see here that your PUZ by AG value, okay, your PUZ by AG value is 14.2, right? You may have the doubt that how I got this PUZ by AG value as 14.2, right? That PUZ by AG value we are going to get from this. We know we are using Fe 4 on 5 steel. Now I need 100 AST by BD. okay, it is 100 AST by BD, 100 AST by AG. AG in the sense nothing but the gross area, that is B into D. So so it is 100 into the corresponding AST value, that is nothing but you have assumed 1. okay, so that is P value as 1. so therefore from that corresponding 100, that is reinforcement percentage, I can take, that is 1%. okay, sorry, not 1%, it is it is 1%, considering the reinforcement as 1%. so that is 100 divided by so you are going to get 100 divided by 400 divided by 500 into 100. okay, you are going to get around so this corresponding, this is nothing but 1%, right? We have taken this 100 AST by BG, that is nothing but the percentage of steel, so that is actually 1%. You can see 1%, I am going to go like this, So this is going to cut this Fe415 here. So come down. So when you come down and by taking FCK, what is the value of FCK we have used? The value of FCK is 25, right? So this is 15, 20, 25, that is here. Yes, it is going to cut 25 somewhere here. And this will be your corresponding percentage, that is between 14 and 16. So you are going to get the corresponding value of PUZ by AG as 14.2. like this you are supposed to get from chart number 63. You will be knowing the percentage of steel, so make it over to 415. So where it cuts, you go down. So according to the corresponding FCK value, so cut the PUZ by AG value, which will give you in Newton per mm square as 14.2. Therefore this PUZ value, which will be, I can write this PUZ, okay, which will be Newton per mm square. So you are going to get as 14.2. that is a value. So from that, since you know the AG, I can get the value of PUZ. Okay, I can get the value of PUZ, that is calculation of PUZ. Okay, so calculation of, I can write PUZ by AG. So now it is calculation of PUZ. Okay, calculation of PUZ, which will be in kilonewton. Okay, so that is nothing but it is this into your 400 into 500. So that will give you the corresponding value. So divided by 1000, which will give you 2840 kilonewton. That is my PUZ. Okay, yes. So once I get PUZ, now I can find out PU by PUZ value, the actual PU by PUZ value. Okay, so I can write actual PU by PUZ. Okay, actual PU by PUZ, so which will not be having any unit. So I can get actual PU by PUZ as this divided by this. So that will be 0.56388. Okay, correspondingly, now I am supposed to find out MUX by MUX1 value. So 20 MUX by MUX1. Okay, that is the corresponding value. Okay, so again no unit. I'm going to get in the initial I forgot, sorry, I have to add 2 more columns here. So along with the axial load, so if I insert okay, if I insert now, so it will be MUX, okay, MUX value which will be in kilonewton meter, and the corresponding value is 150. Similarly, I can write MUY value which will be the corresponding 100. Okay, so now this will be MUY, this will be MUY. So therefore the corresponding MUX by MUX1, if I want to calculate, I can get what is MUX, it is 150. Okay, so MUX will be 150 divided by MUX1, this one, which will be 0.75. Then similarly this will be MUY by MUY1, MUY by MUY1. Okay, so that will be, so corresponding MUY divided by MUY1 is this one, which is going to be 0.64. Okay, so therefore from the value of PU by PUZ, okay, so I can insert better one more here. Okay, yes, so from the value of PU by PUZ and MUX by MUX1, now what we do is, now using this PU by PUZ value and the corresponding MUY by MUY value, we will go to the corresponding, now we can consider it as an what is that, uniaxial column, and going to the point chart 64. Why chart 64 is, since I am taking PU by PUZ, MUY by MUY1, so MUY by MUY1 is based on this, that is 0.15. So therefore I have to go to chart 64 now, sorry, not chart 64, sorry. Now go to the chart 64, which will be used for the biaxial bending, that is, you have the corresponding PU by PUZ value here. We have PU by PUZ as 0.56. Okay, I can make it to 0.56 is there, 0.6 I can go, 0.4, then 0.5, 0.6, this line, and the corresponding MUY by MUY1, that is 0.64 is there. Okay, 0.64, I can go to 0.65. Therefore when I go corresponding here, and when I come down, I am going to get MUX by MUX1 value. Okay, I can call that as MUX by MUX1 permissible. Okay, MUX by MUX1 permissible. So therefore I can write here this as, in the box I can write MUX by MUX1 PRMISSIBLE permissible value. Okay, the corresponding permissible value. Okay, right, so this corresponding MUX by MUX1 permissible value we are going to get from the chart as 0.65. This value of 0.65 what you got should be greater than the value of MUX by MUX1, that what you calculated here. Okay, you calculated, no, that is MUX by MUX1 0.75, which is actually 0.75, but this permissible value is 0.65. So this MUX by MUX1 should not be greater than permissible value. That means the percentage of steel that what I have assumed is not sufficient. So that means you have to increase, or you have to change the percentage of steel. So by changing the percentage of steel, you have to do the process again. Okay, so like that, when we are doing the design of biaxial column theoretically, we are supposed to follow this procedure, which is a long procedure. So therefore in the next class we will learn that how to shortcut this method, how to consider the biaxial movement into the design consideration, and how to reduce the step. Right, so let us finalize this. Okay, Okay, so let us finalize this now. That means the design is not safe, so let us make the design safer now. Okay, yes, so let us okay, so therefore let us change this percentage of steel value. Okay, and after that anyhow lateral type design, everything that will be there, that is not going to change here, same as that of the uniaxial only. So now since it is not getting safer, so we have to redesign it. Okay, so by increasing percentage, so this everything will remain same, but let us consider the percentage of steel as 1.5. when I do 1.5, my P by FCK becomes 0.06, and your corresponding, now when I do this D dash by D, your MU by FCK BD, right, your MU by FCK BD also you are going to get change. Yes, so this will be 0.1, 0.32, no change. Okay, your P by FCK, okay, yes, your D dash by D anyhow it is going to same as it is. PU by FCK is 0.32 only. Therefore, I am going to get the corresponding MU by FCK value from the corresponding chart. I am going to get 0.097. So this will be 0.097. So when this is 0.097, your MU x1 becomes 242.5. Similarly, this D dash by D will change. This it will remain same. PU by FCK will remain change, but corresponding MU by FCK in the another direction it is going to change as 0.09. So when you do 0.09, your MU y1 becomes 180. Right, now after that again, in order to calculate this, so the corresponding chart if you go, that is 100 AST by BD, from that getting the PUZ by AG value, you're going to get 15.8 now, 15.8. so therefore your PUZ becomes 3160. So therefore your actual PU by PUZ now is 0.506, and corresponding MU by MUY1 is 0.55. So from that you are going to get your permissible value as 0.7. Okay, so this 0.7 is much more higher than this MUX by MUX value 0.61. Therefore that percentage of steel is more than sufficient. Right, so like this we are supposed to design the biaxial loaded column. So we will continue the shortcut method in the next class. Thank you, learners.